Welcome. This is Ouroboros, a space for thoughtful inquiry, where science, meaning, and humility meet. In this video, we'll explore what the double-slit experiment actually shows, and what it doesn't. There is an experiment in physics so profound, so utterly mind-bending, that it has puzzled the greatest thinkers of our time. It's called the double-slit experiment. It probes the very fabric of reality. But with great mystery comes great misunderstanding. People attach all sorts of mystical, magical ideas to it. They talk about consciousness changing the world just by looking at it. That is simply not what the data shows. Today, our mission is to bust those myths. We will walk through this famous test, step by step, with calm authority and clear facts. We are going on a journey to the quantum realm, not to find magic, but to find a deeper, more elegant truth about the universe. The experiment is, at its heart, beautifully simple. Imagine you have a wall with two vertical slits cut into it. You stand back and you throw things at it. Let's start with something familiar, like marbles. On the other side of the wall, there is a detector screen that registers where each marble lands. As you would expect, the marbles that make it through pile up in two distinct lines, right behind each of the two slits. This is particle behavior. It's intuitive. It's what you see in your everyday life. The universe, on this large scale, seems to play by rules we can all understand. The marbles behave like, well, marbles. Instead of marbles, let's send waves through the same two slits. Think of water waves in a tank. As the waves pass through the slits, they spread out like ripples from two different points. These new ripples interfere with each other. Where the crest of one wave meets the crest of another, you get a bigger wave. Where a crest meets a trough, they cancel out. The result on the detector screen is not two simple lines. Instead, you get a series of many bright and dark bands, a pattern of alternating intensity. This is called an interference pattern, and it is the unmistakable signature of a wave. So we have two clear outcomes. Particles make two lines. Waves make an interference pattern. The stage is now set for where things get truly interesting. We are ready to ask the universe a very specific question. What happens when we use the fundamental constituents of reality, like electrons, photons, the particles of light? Are they particles, like the marbles? Or are they waves, like the water? The double-slit experiment was designed to get an answer, and the answer it gave us has reshaped our entire understanding of the cosmos, forcing us to confront the strange and wonderful rules of the quantum world. We turn on our electron gun and fire a whole stream of them at the double-slit wall. We look at the pattern that builds up on the detector screen behind it. What do we see? Not two lines, as you'd expect from tiny particles. Instead, we see the very same interference pattern we saw with the water waves. Many alternating bands of high intensity, many alternating bands of low intensity. This is a stunning result. It seems to tell us that electrons, which we have always thought of as discrete particles, are behaving like waves. They are apparently passing through both slits at once and interfering with themselves. This is where the real head-scratcher begins. You might think, okay, maybe the electrons are just bumping into each other and creating this pattern. That's a fair guess. So, let's adjust the experiment. We will turn the intensity of our electron gun way down. So far down that only one single electron is fired at a time. One electron leaves the gun, travels to the wall, and makes a single, solitary dot on the detector screen. It lands in one specific place, just like a particle would. There is no wave to be seen. But we are patient. We let the experiment run for a long time, firing one electron after another, collecting thousands of these individual dots. As the dots accumulate, something extraordinary emerges. The collection of thousands of individual particle impacts slowly reconstructs the very same interference pattern we saw before. The bands of high intensity reappear. The bands of low intensity reappear. This is the central mystery. The particle seems to, know about the existence of both paths, even though it can only take one. The universe is telling us that these fundamental entities are not simply particles or waves, they exhibit properties of both. This behavior is described by the mathematics of quantum mechanics. The theory assigns a wave function to the electron, This isn't a physical wave, but a mathematical wave of probability. It evolves according to a precise equation, spreading out and passing through both slits. The height of the probability wave at any point on the screen tells you how likely it is that the electron will land there. The wave function beautifully predicts the interference pattern. But when the electron actually hits the screen, when it is measured, it gives up its wave-like ambiguity and lands in a single spot. The particle nature reasserts itself upon interaction. This is where the clickbait articles and mystical gurus get it all wrong. They hear that observing the experiment changes the outcome. They claim that human consciousness itself is the cause. The idea is that the universe knows you are watching, and so it changes its behavior. This is a powerful, romantic notion, but it has absolutely no basis in the science. The term observation in quantum physics is an unfortunate and often misleading choice of words. It has nothing to do with a person, a mind, any form of consciousness. It simply means a physical interaction. Let's be precise. How would you observe which slit the electron goes through? You would have to put a detector there. Place a device next to one of the slits that flashes a light whenever the electron passes by. Now you can run the experiment again, firing one electron at a time. For every electron that lands on the screen, your detector will tell you, yes, it went through this slit. No, it went through the other one. You are now gathering information about the electron's path. You are observing it in the quantum mechanical sense. What happens to the pattern on the screen? The interference pattern completely vanishes. Gone. Instead, you now see two distinct lines, exactly like the pattern the marbles made. But why? Is it because the electron is shy? No. It's because your detector, your measurement device, had to physically interact with the electron to get that information. It might have bounced a photon off it or used an electric field. That interaction, that tiny physical nudge, is enough to disturb the delicate wave function. This is the crucial point. The change in the outcome is caused by a physical process, not a mental one. You could have the detector record the data automatically and not have a single person look at it for 100 years. The result would be the same. The interference pattern would still be gone. The observer effect is really an interaction effect. To learn something about a quantum system, you must touch it. And when you touch it, you inevitably change it. There is no way to gain information about the particle's path without fundamentally altering the conditions of the experiment, and therefore its outcome. It has not revealed any psychic powers or shown that reality is a figment of our imagination. Instead, it has given us three profound and concrete truths about how the universe works at its most fundamental level. These truths may be counterintuitive, but they are based on rigorous, repeatable experiments. They are the bedrock of quantum mechanics. The universe is under no obligation to make sense to you, but it does follow its own consistent rules. First, the experiment shows the classical distinction between particles and waves breaks down. Things like electrons and photons are not one or the other. They are quantum objects that exhibit properties of both depending on how you interact with them. Wave-particle duality. Measure particle-like properties by detecting which slit it goes through, and you get a particle-like result. Second, measurement is an active, physical process. You cannot be a passive bystander. Measuring which path did it take is not just looking. It requires a physical interaction that transfers energy and information. That interaction disturbs the system and changes its subsequent behavior. The wave function, which describes all possible futures, collapses into a single, definite state because you forced an interaction. No magic, just physics. Finally, the experiment teaches the probabilistic nature of reality. Quantum mechanics cannot predict one event's exact outcome. It cannot tell you precisely where one electron will land. What it can do, with breathtaking accuracy, is predict the statistical distribution of many events. It predicts the probability of an electron landing in any given spot, and thus the overall interference pattern. The universe at its smallest scales is not a clockwork machine. It is a game of cosmic chance, governed by probability. Keep looking up.